Hi, this is Michael Sullivan, author of Statistics Informed Decisions Using Data. What I wanted to do was point out to you some of the new features that exist in the 6th edition of the text. First and foremost, we have over 350 new and updated exercises. The 6th edition makes a concerted effort to require students to write a few sentences that explain the results of their statistical analysis. To reflect this effort, the answers in the back of the text provide recommended explanations of the statistical results. Not all of the exercises are computational or require statistical analysis. Many of the exercises have been written to require students to explain statistical concepts or understand pitfalls in faulty statistical analysis. There are also over 100 new and updated examples. The examples continue to engage and provide clear, concise explanations for the students. Now let's get into some of the new features. One new feature that we've added is something that we call the threaded tornado problems. Throughout the text, a single large data set that measures various variables on all tornadoes that struck the United States in 2017 is utilized. The problems are marked with a tornado icon. The list that you're seeing here is also available on the front inside cover of the text and shows the sections, problems, and topics covered along with the pages for the threaded tornado problems. In addition, I wrote corresponding MyLab problems around this data set that I'll show you later. The problems that you're seeing could serve as a semester-long project for your students, so students can see the wide range of statistical analysis that can take place on a single data set. I also want to talk about the optional simulation and randomization sections that are new. Simulation and randomization methods are a new approach to hypothesis testing. So new to this edition are optional sections on using simulation to test hypotheses for a proportion. That's section 10.2a. 10.2b then follows up on that with hypothesis tests for a proportion using the normal model, so students can see how the two approaches compare to each other. We have simulation and the bootstrap method to perform hypothesis tests on a population mean, and randomization tests for testing hypotheses on two independent proportions in section 11.1a and two independent means in 11.3a. Section 11.2a uses bootstrapping to conduct inference on two dependent means. Finally, in section 14.1a, we use randomization techniques on the slope of the least squares regression line. So you, as the instructor, can use these sections to introduce the ideas of simulation and randomization to your students, while at the same time maintaining the traditional topics that you have in an introductory course. So now let's look at some of the updated MyLab problems. I've added 4 new types of problems to this revision. One is applet exercises, second are real database problems, third are the threaded tornado problems that I just mentioned, and fourth are essay questions. Let's have a look at each of these. So here we are in section 4.1 on scatter diagrams and correlation, and we have 4.1.app1. If I click on that, here is the correlation by iApplet. And so we take students through a variety of questions, asking them to work with the applet, be engaged in the material, and learn statistical concepts. So for example, we want to create a scatter diagram of 12 to 15 observations with positive association. So we open the applet, click Reset, and you can see we can just click in the applet to create a scatter diagram. And then down below, at the bottom of the applet, you can click Show to see the correlation. You can move points around in the applet to see how the correlation changes with different points in a different scatter diagram. So these are assignable and gradable exercises now in the MyLab program. Here we're in section 8.1, and you can see we're working on problem 8.1.SC-1. The SC stands for StatCrunch. The StatCrunch exercises are based on real data problems. I'm sure you've all noticed that in the MyLab program, because it's algorithmically generated homework problems, oftentimes the problem that it is based on in the text loses its flavor because we have to make it generic. And so you'll see country A, country B, politician A, politician B. What I've done is identified large data sets that we can utilize to write real data-based problems. So for example, here, the city of Los Angeles has the Metro bike share system. And so we have this data in the MyLab problem. The data loads into the MyLab spreadsheet, and we can do all kinds of analysis on this data. So for example, the first question says draw a histogram of duration. I would expect my students to title the graph, but I'm going to skip over that. And there you can see the histogram is highly skewed to the right. And so it looks like it's this one. And so the distribution is skewed to the right. And you can continue going through this, playing along, where we're finding the population mean, and we're going to start doing some sampling from this large data set. So I think that that's going to make the course more authentic for the student and allow the student to see how real data can be analyzed within the MyLab program. You'll also notice periodically you're going to come across real database problems that aren't marked as SC in the course. So here's an example of a real database problem that's not StatCrunch based. So this is based on problem 18 in section 11.3. Again, notice that because I'm using real data, we can have actual scenarios. So here we're comparing wait times at Pirates of the Caribbean and Splash Mountain in Walt Disney World. So again, this gives the course a sense of authenticity while working within the MyLab program. Essentially what's happening in the background here is we're using an algorithm to randomly sample from a population data set containing wait times at Pirates of the Caribbean and wait times at Splash Mountain. And so it's still algorithmically generated problems because we're randomly sampling from a larger data set. Here, 11.3.17 is one of the threaded tornado problems. So I'm not going to go through this, but you can basically see that it's based on problem 11.317 from the textbook on your threaded tornado problems. And then lastly, I want to show you the essay problems. Essay problems aren't going to appear as part of your study plan, so I'm going to have to go and show you where they are when we go into the assignment builder. I'm just going to pretend that I'm creating a test, but this can be done as in a homework assignment as well as a quiz. I'll call my test blah. And let's say I'm in section chapter 3, section 1. Here's an essay question, 3.1.17 essay. And so here I think we have 3 histograms, and we just want the student to identify what the relation is between the mean and the median in this particular problem. Here I am in chapter 4. Let's say I'm in section 4.2. This question, we have actual data, and we have to find the least squares regression line, interpret the slope, so on and so forth. So you can see the idea in my mind for these essay questions is to allow you to use the MyLab program now to give exams. So I've always given exams in the MyLab program, but felt like the exam was a little bit shortchanged when I didn't have as many essay type questions. So now I'm going to be able to give exams in MyLab with algorithmically generated problems that are free response, and then I'll grade them by hand. So to me, this is a really nice feature to add into the MyLab program. Next, I want to talk to you about the classroom notes. So if you go back to the main menu, the classroom notes are going to be located right here. They're in the process of being developed, but I'll show you what they look like. So here are the classroom notes, for example, for Chapter 4. They're basically what you could think of as cliff notes for the text itself. We listed out all the objectives for a given section, used the definitions and procedures that are from the textbook itself. However, we were very, very careful in making sure that the examples are different from those in the textbook. That way, you provide the students with yet a different scenario under which we're doing any kind of data analysis. In addition, we made them a little bit flexible. So for example, here, you get to go to Zillow.com and compare the Zestimate to the selling price for any given neighborhood that you like. That way you're collecting data on the fly. If you don't want to do that, we have a stagnant example here as well. And then what you would do as the instructor is fill these in as you're going through your lecture, and the students could do the same thing, and then they're building out their notes. It really is helpful for the instructor because you don't have to find alternate examples, and it's helpful for the students because it gives them a chance to organize their thoughts and develop good note-taking skills. And so, lastly, we find this to be a really, really great resource for anybody that's new to teaching introductory statistics. And so I think you're going to find this to be a valuable tool. Oh, and by the way, we also have activities in here. So these use applets, and you can kind of go through the applet and show students or develop concepts for students in an engaging manner. We also have a new Learning Catalytics course that's available to you. All you have to do is send me an email, and I'll email you back a link to the course. So you can email me at sullystats@gmail.com if you want a copy of my Learning Catalytics course. It was written in conjunction with George Woodbury. So if you're not familiar with Learning Catalytics, you can think of it as a clicker system. It's included as part of the access fee to the MyLab course. Your sign-in is the same sign-in that you use when you for your registration for MyLab. And so here's my course from last spring. You can see that I've utilized this course already, but so for every single chapter of the text, we have corresponding exercises that you can deliver to your students using the Learning Catalytics program. Some of these questions are free response, some are multiple choice, some are many choice. We have matching, we have ranking, a wide variety of exercise types for you to utilize in the classroom. I personally use Learning Catalytics for two different things. First, I use it in a flipped classroom environment. That way I can do targeted learning. Secondly, I use it as a review tool. I also have a little video at sullystats.com that shows how I've utilized Learning Catalytics in the past. We've also added new videos to the 6th edition. The two new video types that exist, the one that you're looking at on the left is a Go Animate style video. It's my voice overlay where we introduce students to various topics. It's used mostly as an introductory tool to the various sections of the course to tie everything together. And then we have also new videos where I'm actually on screen developing statistical concepts. With the help of my nephew, Patrick Murphy, we've written now an R technology guide that can be used with the textbook. So the R technology guide is in the MyLab course. It is available under the Video and Resource Library under Learning Tools. So there's the R manual. It's by chapter, and it goes directly along with the material in the textbook. So if you're working in Chapter 9, these are the R commands that you would utilize in order to answer the question or do the examples that are the examples in the textbook. And so it's a very helpful tool if you're going to be using R in your classroom. And then last but not least, I want to talk to you very briefly about the Corequisite materials that are fully integrated into the 6th edition. So if you go under e-text contents, you'll see that this is the statistics material, and then right below it we have the corresponding integrated review or Corequisite material. So chapter 1 of stats doesn't have a lot of math as a requirement, and so while the student is working on chapter 1 of stats, if the student needs is in a Corequisite environment, they could be working on chapter 1 integrated review, getting ready for chapter 2. So this material lists out all the types of things that the student would need in order to be successful in chapter 2 of statistics. You can read how the course is laid out, but it's essentially the student takes a skills check quiz. If the student passes that quiz, they're done with the correct material. If they don't pass the quiz, they have to take quizzes on each individual section, and then if they pass that, they can move on to the next section. Otherwise, there's going to be remediation required in the form of a personalized homework. In addition, we have videos for every single objective. There's a full textbook available with the Corequisite material along with worksheets. So I'd encourage you to look around in this area of the website. I have it set up so that the students are using quizzing to identify the skills that they need to shore up, but you could also set this up as a full MyLab course as well. So I didn't want to spend too much time talking about the Corequisite material, but I wanted to let you know that it has, every objective has a video, there's a full textbook with it, and all the problems that are in the textbook are programmed into the MyLab course. So if you are teaching a Corequisite type of course, we have all the resources that you're going to need. So as you can see, we've added quite a few new features to the textbook that we hope you enjoy, and we hope that your students find them to be beneficial to their learning and understanding of statistics.